Hello and welcome back to Math 151. We are going to be working on today lesson 5.7, which is going to be called the inverse trig functions. And inverse meaning we're kind of just like what we did back in chapter 3, I think it was, where we took our y's and we switched them with our x's. And that's basically what we're doing, but with the trig functions. So instead of using angles and finding the arc length, we're now saying we know the arc length or the length of this slope, but what angle would refer to that? And so we're kind of going in the opposite inverse thinking. So there's a little bit of notation to that thinking. It's right here, arc sine here on page 482. The arc sine function is defined by this. The arc sine of x is equal to y if and only if x is equal to the sine of y. So because the domain of the arc sine is -1 to 1, the range is a -π/2 to π/2. So we've now switched our domain and our range with the regular sine function. Okay. And that's what's going to happen with the domain and range of the cosine and the secant, cosecant, the tangent, cotangent. So essentially, we're just using this to go in the reverse direction. That's essentially what it is. So we're trying to think backwards. So I'm going to just go straight to some of the problems so that you can kind of see this. To me, this lesson is really just used as a way to access a different thinking in reverse. And so let's just jump there. I'm going to go ahead and share my screen. And let's just start looking at some of the. So one thing is on notation here. The book is going to mainly write arc sine of x. It's the same as the sine to the -1. It does not mean the 1 over sine. So sine of a -1 of x does not mean 1 over sine of x. It's not the reciprocal, it's the inverse. Okay. So for instance, number 5 says, find the exact values of the given trig functions without using the calculator. So number 5 says the arc sine of 1. So we are asking ourselves, what angle, what radian angle measure would give us a length of 1? And that is at π/2. So that's what we're doing. This can also be found in your calculator. So you can see here that let me look at so you can see. You can see here we have the sine, cosine, tangent, and then above in the blue, we have the inverse sine, inverse cosine, inverse tangent. So if I do sine of π/2, which π/2 is a 90-degree angle. I'm in degrees currently. So if I do sine of π/2, which is 90 degrees, I get a 1. And if I do the inverse sine, so sine to the -1 of 1, it's going to refer to me as 90 degrees. So that's what they do, is they interchange each other. So number 9 says arc tangent of 0. So when is my tangent function 0? So my tangent function is 0 when sine is 0. So tangent equals 0 when you have a 0 over 1. So my sine over my cosine. So basically, where is sine 0? So tangent, you can see, is 0 when sine is 0. And that happens at 0 and it happens at pi. So arc tangent of 0 is 0. 13 says, what is the arc cosine, the inverse of the cosine at -√3/2? So we know that cosine is negative in the second and the third quadrants. And a √3/2 for cosine happens at π/6, 30 degrees. And then it happens again at all of the cycles after that, pi over 6, and then 5 pi over 6. It happens at those. So square root of 3 over 2. But it's negative at pi over 6, which is the same as 30 degrees. Well, 30 plus 90, because it's in the second quadrant. So it's going to be 120 degrees. So let's just verify that. We're going to do the inverse cosine of a negative square root of 3 over, delete that. Okay, make sure you're not underneath the square root anymore. Divided by 2. And it's going to be at the 150. Oh, pi over 6 is 30 the other way, so it's, yeah. Pi over 6 is the reference angle at 30 degrees. So that means it'd be 180 minus the reference angle, which would be 150 degrees. So 15 says, again, find the exact value of the inverse tangent at a negative square root of 3. So where is tangent negative? Tangent is negative where sine and cosine are opposites. So sine and cosine are the same in the first and the third. So they're opposites in the second and the fourth. And it's the square root of 3. So where is tangent, the square root of 3? Tangent is the square root of 3 at pi, 3 pi over, so pi over, I think it's the 5 pi over 6. So let's just look this up again here. So looking at the table that we've made, we're looking just to see where tangent is a square root of 3. And we can see that tangent is a square root of 3 at pi over 3 or 60 degrees. But we want to know where it's negative. So that is going to be in the fourth quadrant. So that's going to be the negative 60 degrees. So a negative pi over 3. Or negative 60 degrees. So problem 17 through 28 are asking us to use the calculator, which we've kind of been learning how to use at the same time, but it says 17 says, find the arc sine or the inverse sine of a negative 1/4. So that means we're going to go to inverse sine and put in a negative 1/4 parentheses, and that happens at a negative 14.48 degrees. Oh, I misread the instructions. I just realized it wants us to have it in radians. Here, radians. So let's erase, let's erase this one. To make sure I re-looked at that, make sure I read that, because it does make a difference if it's asking for radians or degrees, and I've been in degrees previously. So this is the inverse sine of a negative 1/4, and it wants, and so in radians it's a negative 0.2527. And 21 is the arc tangent of 5. So we're going to do the inverse tangent of 5. And we get 1.3734. And then 25 is the arc cosine. So we get practice with that one, the arc cosine of a negative 0.95. And that comes out to be 2. So this is 2.824. Inverse cosine of a negative 0.95. So remember, you're using your second key because we're using the arc. Now, problems 29 through 38 are saying evaluate each trig function using a calculator without using a calculator. So we're going up here to 29. And 29 says, find the inverse cosine or arc cosine of cosine. Well, they are inverses of each other. So it should just be pi over 3. Because cosine at negative pi over 3 is still positive there. And so the inverse of that positive is going to be the positive of pi over 3. Because cosine is positive in the first and the fourth quadrants. So number 33 says tangent of the inverse tangent of 4. And they are inverse functions of each other, so it's just going to be 4. Now, 35 says find the sine of the inverse of cosine of 12 over 13. So we have to first say, okay, so what is the inverse of cosine of 12 over 13? And let's just go, whoops, let's just go to our back to our degrees. And let's do the inverse of cosine 12 over 13. And that comes out to be 22.6199. And so then we're going to say the sine of 22.6199. 22.6. And that comes out to be 0.3846. Which, that's point. And so if we do the second and math of that, whoops, no. If we do the alpha and math, alpha and y equals of that. We have 0.3846. We want to do that. So essentially, this 12 over 13, because cosine is the adjacent over the hypotenuse, we're basically just filling out our right triangle for this one. I'm just trying to show the ratio of this. Let's see if I put it in radians for just a moment. And if we go back to do the inverse cosine, our original, our inverse cosine of 12 over 13. It's going to give us that. And then if we say sine of the answer of that So it gives us the same decimal. So I'm trying to show that it's 5/13. 5/13 is that same fraction. I'm just trying to show you that this is that perfect triangle of 5, 12, 13. And because the decimals are rounded, it's not quite working out that way. 37 is going to be similar. 37 says, find the cosine of the inverse cosine of a negative 12/13. So a negative 12/13 means where is sine negative? So sine is positive in the first and second, but sine is negative in the second and fourth. So second and fourth quadrants. Okay. And so we basically, let's drop the So let's start like this. So we've got this. So let's say we're in the fourth quadrant and so sine is, and the hypotenuse is positive. Yeah, so sine is negative here. So it's going to be the opposite over the hypotenuse. So the opposite is going to be 12 and 13. Again, it's a special triangle. So we know that 13b is going to equal the square root of 13 squared minus 12 squared. Squared minus 12 squared is going to be 5. So this side is 5. And so if we do the inverse, if we have our mode in degrees, and we do the inverse sine of a negative 12/13, it's going to be at this degree, 67.38. And then if we do the cosine at that, the cosine of the answer is going to be 0.3846. So the answer should be the 0.3846 that we had in the last problem, but we all know that that's also equal to 5/13 because we drew the triangle. They're kind of funky ones to work around. In decimals, I think it would come up with that angle, that ratio better, 5/13. Let's just go to decimals just to try it there so that you can all see. Okay, so if we did the inverse sine of a negative 12/13. And then we do cosine of that negative 1.176. Okay, so then we get this answer, 0.38. So if I don't think we can turn that into 0.38 4620190. If we do this, if we click on it, I don't think we can make it turn into a fraction. Yes, it's still the fraction of 5/13. I just can't, it's not working out that way to show the perfect fraction here. Okay. We're going to move on to something else. So 45. 45 says, explain why each of the following expressions is undefined. So explain what arc cosine of 4 is undefined. Why is it undefined? If we look at arc cosine, it's only defined between let's go back and show where that's defined in the book. So it's only defined between a -1 and 1, and that's why. It can't be defined between at 4. And then cosine, again, 49. 49 is asking us to find the exact values of the given expression. So we're going back to some evaluations here. 49 says, find the exact value of the 49 says cosecant of a -1. I wrote that as cosine. So this 49 should be cosecant of a -1 of square root of 2. And so cosecant, where is cosecant of square root of 2? Cosecant of square root of 2 is right here at pi/4, 45 degrees. So this would be pi/4 or 45 degrees. And then 51 says, let's look at that one. The inverse of secant or arc secant of a -2 square root of 3/3. So where is secant? Secant is 2 square root of 3/3 at pi/6. But where is that negative? Secant is negative where cosine is negative. So in the second and third quadrants. So second and third quadrants, a -2 square root of 3/3. So that would be at 5, the reference angle, let's mark that reference angle is pi/6. So that means the angle in, so in quadrant 2, it would be 5 pi/6. Okay, I want to make sure that you understand that. So when we use our table here, the table that we've been making, it's all of our reference angles, but we have to know what quadrant we're working in and go back to that. So our reference angle is going to be pi/6, but because we're talking about a negative secant, where is secant negative? It's negative in the second quadrant, and so that's 5 pi/6 there for number 51. You might see that, it's 51. Okay. 57 and 61, back to the calculator. It says find the exact values of the given expressions in radian measure. So we need to go back and through and make sure that we are in radian measure. So let's turn on our mode here. Make sure we're in radians, and we are in radians now. So it says find the inverse secant. So inverse secant is, because secant is 1 over cosine, so it's 1 over the inverse of cosine at 2.5. So we really have to do 1 divided by, so the reciprocal of, let me show you here, 1 divided by the inverse cosine at 2.5. Oopsie here. Which is let's see, what did I put that in the right? No. At 2.5, I wrote 2.4, 2.5. Oh, cosecant is sine. Secant is cosine. Just want to be sure I've written this down correctly here. Just 1 minute. Okay, I just wanted to make sure that I had this written down correctly because of my bifocal. Sometimes I read the book incorrectly. So 57 is the inverse secant of 2.5, which means that this is the reciprocal. Incorrectly. It is the reciprocal, but it is actually the inverse cosine of the reciprocal of 2.5 because secant and cosine are reciprocals of each other, but it's the reciprocal and the inside. So that's where I misquoted myself. So let me get it up here. So we're going to do the inverse cosine. Make sure your degree, your mode is in radian. So inverse cosine of 1 divided by the 2.5, which is 1.159. And it said 4 decimal places, so it's 1.1593. 1.1593. Now 61 says find the inverse cotangent of 2.4. So cotangent is the same as the inverse tangent of the reciprocal, so 1 over 2.4. So we're going to do the inverse tangent of 1 divided by 2.4, and we get 0.3948. Okay. The last 2 problems that I'd like to do are from the application section. And the first one is number 65. So let's just read that one together. It says, it's about surveying land. It says a surveyor finds that the tangent theta of 19/5, where theta is the angle that a straight line from the ground makes with the top of a platform. Find theta in degrees. A surveyor is somebody that measures land or property if you were going to sell or buy some property. So I drew my picture here, and it's the angle, the tangent. So tangent is always the opposite over the adjacent of the angle. So the opposite would be the 19 over the adjacent side. And it says find the angle of that. So we're going to do the inverse tangent of 19/5 to find out the angle. And they want it in degrees, so we're going to put it in degree mode. So we're going to go ahead and put in degree mode. And then do the inverse tangent of 19/5. And so we get the angle is approximately 75.26 degrees. Then number 69, my drawing is not great on this one. Number 69 is talking about roofing. It says a smokestack cut from a right circular cylinder is to be attached to a roof of slope 4/5. At what acute angle to the horizontal should the cylinder be cut so that it matches the angle of the roof? Express your answer in degrees. So I drew my right circular cylinder, I think. But I do know that slope is rise over run, and so that is 4/5 of this angle. And it says at what acute angle to the horizontal matches the roof. So again, this could be the tangent of the angle is equal to 4/5. So we can do the inverse tangent of 4/5 should equal our angle for that one. And so inverse tangent of 4/5 should equal 38.69. So the angle theta is approximately 38.66 degrees. So you did it. You made it through chapter 5. And this should be all new items, I'm guessing, trigonometric things. So catch me back for lessons. We're going to do 6.1 and 6.2, which are a few additions to some trig ideas. We're going to look at the trig identities in chapter 6. And then that will wrap up our next exam. So see me back for chapter 6.1 and 6.2.